With you, I think Switzerland could become maybe an example, a benchmark how to do that without the confrontation aspect, right? The world needs solution. That's the subject of the World Economic Forum this year is dialogue, right? How can we build bridges versus breaking them? So maybe Ribordy, Gregoire, you founded ID Quantique. That was actually, we were the two first startups in Switzerland, right? Wisely 27 years ago, something like that. And we were actually at the beginning of the e-voting project in Switzerland when we deployed the first ever binding e-voting project online using a mobile phone and a screen. You have evolved all the way into the full quantum spectrum, but quantum is many things. Maybe can you break for the audience what is really the quantum stack and where you position yourself on that stack, and maybe also about the qubits requirement in order to have something like a threat in this sector.
Yes. Yes, you're right. You know, we both started companies very early. Now, I typically say that I started IDQ in the quantum field probably 15 years too early. So, you know, if I tell you something about timing, don't listen to me or take it with a pinch of salt. Yeah, so quantum, you know, quantum is the science that was developed in the first 30 years of last century. And there was a first quantum revolution. This is all the IT technology that we have today comes from quantum, you know, semiconductors, lasers, but it's quantum when you use a lot of quantum objects together. And we're now at the beginning or the end of the beginning of a second quantum revolution where you use individual quantum objects to do things that are not possible with classical technologies. And there are essentially three areas. One is quantum computing, using qubits, so encoding information on quantum objects, and that allows you to make calculation much faster, super useful in optimization, AI, drug discovery. But also it brings a threat, the so-called Shor algorithm, which was invented in 1994 by Peter Shor, and that allows to factor large integers and break the cryptography that we use until now, more or less. And you know, and that's a challenge. One way to address this risk is post-quantum cryptography, but also using a second area of quantum communications, using quantum object to send information. And so if you send photons, particles of light, in an optical fiber, typically in classical communication, you send millions of photons per bit. And so it's possible to intercept these pulses by, you know, just taking a few % of the light, you get 100% of the information. Now, if you send one photon at a time, it's a quantum object, and in quantum, if you measure something, you modify it. So that allows to detect perturbation. A second application of quantum communication is to connect quantum computers. Because just like with classical computers, when you build a computer at some point, it becomes economically better, instead of making a bigger one, to just make two and network them. And the third pillar of quantum technologies is sensing. Of course, if you use very fragile objects, these are good to measure physical properties. So you can use quantum technologies to measure the magnetic field, gravitational field, application in positioning. And so these are the three fields of the second quantum revolution. And I would say, you know, now is really the time. And I think the next 5 years are going to be extremely interesting. We heard in the very first panel this morning by a gentleman from IBM that they're planning to have a quantum computer that can break RSA in 2029. 2029 is tomorrow. You know, if you look at the security infrastructure that we use and that we need to upgrade, it is tomorrow. And so that's an important thing to note is that we, as all organizations, must have a quantum strategy.